Most businesses today are spending a large share of their AI budget on cloud-based services for everyday repetitive tasks. And by cloud-based, I mean tools like ChatGPT, Claude, and Gemini. These tools are useful because teams can start quickly. They don't need to buy hardware, install models, or maintain technical infrastructure. But that ease of access comes with two issues every manager should understand. First, API bills can rise quickly as more employees, workflows, and automated processes start using the service. Second, every time your team sends information to a third-party AI server, some customer records or internal business data may leave your own systems. Today's video isn't about telling you to abandon the cloud immediately. Instead, Implementa Labs wants to show you another option your business can test: local AI infrastructure that can run fully offline. This gives your team a way to keep AI work inside the business, reduce dependence on one platform, and build a backup path before you actually need it. Putting all of your AI workflows in the cloud can feel a little like running your business from rented space. It works while the terms stay the same, but with rented access, you don't fully control the price, the rules, or whether that access will always be available. The provider can change prices, update security rules, limit features, or face legal pressure that affects your tools. If your daily workflows depend completely on that provider, those changes can affect your team right away. The cost problem shows up most clearly when the work runs all day. If you're using cloud AI for tasks like data scanning, email classification, document sorting, or customer message tagging, every request can create another API charge. As usage grows, the cost doesn't just increase once, it keeps increasing every time the workflow runs. A practical way to think about this is to build a hybrid system. Cloud AI is like the national power grid. You still use it for work that needs deeper reasoning, larger context, or the best available model performance. But alongside that grid, you could also add a backup generator inside your company's own garage. Local AI is that backup generator. It doesn't fully replace the grid, and it doesn't need to. Its job is to give your business a fallback option for work that can safely run on your own machines. Once the hardware is paid for, those local tasks can run without adding a new API charge each time. More importantly, your team has another path if cloud pricing changes, a provider goes down, or access is suddenly restricted. One reason many business owners and executives hesitate to explore local AI is that they assume it requires programming knowledge or a deep technical setup. In reality, your first test doesn't need to start with code. You can use a no-code path, test the idea inside one department, and then decide whether it's worth a larger investment. Instead of starting with terminal commands, you can use software with a visual interface. A common starting point is LM Studio. If you're not familiar with it, think of LM Studio as an application that helps you search for AI models, download them, and run them on your own computer. The setup feels closer to installing a normal Office application than building a technical system. You go to the official website at lmstudio.ai, download the installer for Windows or Mac OS, and follow the installation steps. Once you open LM Studio, you'll see a graphical interface. The model search bar appears on the home screen, so you can choose a model, download it, and start chatting with it in a window similar to ChatGPT or other AI assistants. That makes LM Studio a useful first step. Your team can see what it feels like to run a model locally, learn what the machine can handle, and build confidence before touching source code or making a bigger budget decision. To test local AI without frustration, you need to match the model size to the computers your team already uses. AI model size is measured in billions of parameters, usually written as a B. In general, a model with more parameters can handle more complex instructions, but it also needs more memory to load and run properly. Start by looking at the computers your team already uses in the office. For office laptops, older MacBook Air devices, or PCs with 8 GB of RAM, keep your first tests small. Look for models from 1.5 billion parameters up to about 4 billion parameters. These models respond quickly, don't put as much pressure on the machine, and can still handle simple text organization, basic summaries, or simple data classification. For computers with 16 gigabytes of RAM or entry-level MacBooks with M-series chips, you're in a good starting range. The setup can usually run models from 7 billion to 12 billion parameters smoothly. That range can handle everyday writing tasks, data summaries, and procedure-based customer response workflows. For graphics PCs with dedicated NVIDIA cards starting from 12 gigabytes of VRAM, or MacBook Pro and Mac Studio devices with 32 gigabytes to 64 gigabytes of unified memory, you can test larger models, such as 14 billion, 27 billion, and up to 32 billion parameters. With this kind of hardware, local AI can work through more detailed instructions, compare larger sections of text, and handle documents with more structure. For internal servers or workstations with multiple GPUs and at least 128 gigabytes of RAM, your company can explore very large models from 70 billion parameters and above. These models are meant for heavier data processing and more demanding internal use cases. But if you're only running your first test, you don't really need to start at this tier. To help these models run without freezing the machine, look for quantized versions. Quantization is a compression technique. You can think of it like converting a large raw image file into a high-quality JPEG. The file becomes smaller, but it still keeps enough data to be useful. When you search for models inside LM Studio, the system will show green or red indicators based on your machine. A simple rule is to choose versions marked Q4KM or Q5KM. These versions reduce the file size while keeping enough of the model's original ability for normal business testing. Once you understand your hardware, the next step is choosing the right model for the job. Choosing the right model helps you test local AI fairly instead of blaming the whole setup when the model simply wasn't built for that task. You can think of the model like an AI employee. Different models are better at different kinds of work. There are currently 3 model families in LM Studio that your business may want to test. The first option is Qwen 3 from Alibaba. This is a good all-around model family for business use, especially when your team works across multiple languages. Qwen 3 has basic versions with 7 billion and 14 billion parameters, and it comes with a commercial license that you can review before using it. It's a practical option for summarizing information, writing emails, drafting documents, or handling basic internal chat responses. The second option is DeepSeek. If your test workflow involves code review, structured data analysis, or logic-heavy tasks, look for DeepSeek inside LM Studio. This type of model is built for more technical work. One thing to keep in mind is that deeper reasoning models often take 10 to 30 seconds to process before returning an answer. That pause is normal. You're trading some speed for better handling of complex tasks. The third group includes Llama from Meta and Gemma from Google. Llama has a large open source customization ecosystem, which means many developers build tools and variations around it. Gemma is often useful for concise writing, structured responses, and clean summaries. Both model families have versions around the 8 billion to 11 billion range, which makes them practical choices for many first tests in LM Studio. Now, if you're wondering where to begin, start with workflows that can be separated from the cloud and tested locally. The basic security idea is simple. If the computer isn't connected to the internet, the file has no direct path to a third-party server during that test. So, for your first local workflow, choose a task that uses internal files, disconnect the machine, and see what local AI can do without sending the data outside your business. A first useful workflow is preliminary processing of internal documents. You can disconnect the computer from the internet, load a text file, and ask local AI to summarize it or extract key information. The entire process happens on the machine. A second workflow is an internal wiki lookup system. Local AI can help employees search operating procedures, internal manuals, or company policies that you don't want uploaded to an external source. A third workflow is high-volume repetitive processing. For example, you can classify raw data files, clean messy text, or reformat batches of content all day without creating a new API token cost every time the task runs. A fourth workflow is periodic business data analysis. Local AI can give managers another way to review margins, operating costs, or recurring performance data while keeping more of the analysis inside the business. A fifth workflow is tech support in areas with poor internet connectivity. This can help employees at field construction sites, on ships, or on long-haul flights continue summarizing, drafting, or reviewing text even when cloud tools aren't available. There's one key point every local AI user needs to remember. Running AI on a personal computer does not automatically make your data 100% secure. If you install unknown software, allow malware onto the machine, or let multiple people use the same computer without separate accounts and passwords, your business data can still leak. For personal laptop users or small companies, you don't need to start with expensive firewall systems or server rooms. Start with these 3 simple security habits your team can easily follow. The first habit is to disconnect from the internet when processing confidential data. This is one of the biggest advantages of local AI. If you're analyzing an internal financial report, a sensitive legal contract, or a confidential customer list, then turn off the Wi-Fi or unplug the network cable before you load the file. When the computer is disconnected, the file can't be uploaded to the internet during that session. After the model finishes processing the file, delete the chat session before turning the Wi-Fi back on. The second habit is do not download models from unknown sources. LM Studio is a useful tool, but it also works like a marketplace. Many users can upload modified versions of models. For a small company, the safer path is to search for official models from companies you recognize, such as Meta, Google, or Alibaba, and check for verified marks where available. Avoid strange models from unclear sources. This reduces the chances of bringing viruses, spyware, and malicious files onto your machine. The third habit is to secure the physical device. Your data now sits directly on the laptop's hard drive, so the device itself matters. Set a strong login password and turn on the built-in disk encryption feature such as BitLocker on Windows or FileVault on macOS. If multiple people use the same office computer, create separate user accounts for each employee instead of sharing one admin account. This helps prevent one department from accidentally seeing or copying confidential documents another department is processing with AI. To use a hybrid system well, you need to know what local AI should handle and what should still go out to cloud AI. The biggest limitation of local AI is the context window. In simple terms, the context window is how much information the model can keep in mind at one time. Cloud AI can often process much larger documents because providers run the models on large server infrastructure. With local AI, that capacity depends on your own computer's RAM and GPU memory. If you load too much information at once, the model may slow down, freeze, or give weaker answers. The key is routing the work. Send repetitive, high-volume, confidential tasks to local AI when they don't require a very long context window. This is how local AI can reduce data exposure and lower repeated usage costs. Send larger, more complex, non-confidential tasks to cloud AI when they need more context, more creativity, or more advanced reasoning than your local machine can provide. The key is to know which work belongs where. So your team uses cloud AI when it needs scale and local AI when it needs privacy, cost control, or a fallback path. The purpose of learning a new technology isn't to chase a trend. The purpose is to give your business more options when costs rise, providers change rules, or access becomes uncertain. With more and more of our work being done with AI, AI infrastructure is no longer just a technical decision, it's also an operations risk decision. We recommend starting small. This week, you don't need to redesign your company structure or replace current tools. Treat local AI as an option to test. Choose one capable computer in one department. Install LM Studio. Pick a model that fits the machine, such as a 12 billion parameter model if the hardware can support it. Apply the local security habits we just discussed. Then test one small workflow, such as summarizing internal documents or classifying a batch of text files. When your team controls even one small part of this technology, the business gains another option for the future. That means if the market changes, your operations don't have to depend on one provider, one price model, or one access policy. If you want more practical, clear, and no-hype ways to improve your processes and use AI safely, make sure to hit the subscribe button. For now, start with a small implementation. Test one local workflow on one computer with one model your team can actually run. Thanks for watching, and I'll see you in the next video.